Our next application of logarithms will be sound intensity. The level of sound, beta, in decibels, with an intensity, I, is given by this formula here. Beta equals, so the decibels equals 10 times log I over I sub 0, where I sub 0 is a constant. It is an intensity of 10 to the negative 16 watts per square centimeter, which is roughly the faintest sound that can be heard by the human ear. Okay, so what does each variable stand for? So beta, that is the level of sound. And that is in decibels. I is the intensity. And that is in watts per square centimeter. I sub 0 is the faintest intensity that can be picked up by the human ear. And I'll just call it faintest intensity, and it is approximately 10 to the negative 16. Okay, so that is an approximation of the faintest intensity that the human ear can hear. Use the properties of logs to expand the formula. So here I have a logarithm with an argument that is divided. So that can be split into two logarithms that are subtracted. So beta equals 10 times log I minus log I sub 0. Okay, so I took this one logarithm with an argument that's divided and split it into two separate logarithms subtracted. Find the level of sound for a faint whisper with an intensity of 10 to the negative 14. So here's the intensity. Let's find how many decibels that is. Okay, so the decibels is what I'm looking for. The intensity is 10 to the negative 14. And then I sub 0 is the faintest intensity picked up by the human ear, which is a constant at 10 to the negative 16. So we have 10 times log 10 to the negative 14 minus log 10 to the negative 16. Now we can evaluate these logarithms pretty easily. So we've got the number of decibels equals 10 times. Now this is log base 10. Okay, if there's no base there, it's a common log base 10. So it's 10 raised to the power that raises 10 to negative 14. So log base 10 of 10 to the negative 14 has a value of negative 14. And log base 10 of 10 to the negative 16 has a value of negative 16. Okay, so now I've got 10 times, and then 14 minus negative 16. That's 14 plus 16. That is 2. So it is 20 decibels. The level of sound is 20 decibels. Find the level of sound with an intensity of 10 to the negative 4, which is the threshold of pain. So once we get to 10 to the negative 4 intensity, that's when it starts to hurt. So we're going to find the number of decibels. Okay, so decibels is what we're looking for. The intensity is 10 to the negative 4, and I sub 0 is 10 to the negative 16. So we have 10 times log 10 to the negative 4 minus log 10 to the negative 16. Okay, so log base 10 of 10 to the negative 4 has a value of negative 4 minus log base 10 of 10 to the negative 16 is negative 16. So we have 10 times negative 4 minus negative or plus 16, and that is 12. 10 times 12 is 120, so at 120 decibels, it's going to start to hurt your ears. The noise level of a typical car engine is 88 decibels. Find the intensity of that car engine. Okay, so this time we know the number of decibels is 88. We don't know the intensity, but we know that the faintest intensity picked up by the human ear is 10 to the negative 16. Okay, so we have 88 equals 10 times log I minus log 10 to the negative 16. Okay, so here I would first divide both sides by 10. So I get 8.8 equals log I minus log 10 to the negative 16. Okay, now log 10 to the negative 16 has a value of negative 16. So this is really 8.8 equals log I minus negative 16, which is plus 16. So I can subtract 16 from both sides. 8.8 minus 16 is negative 7.2. So negative 7.2 equals log I. Okay, now this is log base 10 of I. So if I want to get rid of this logarithm, I can put a base 10 on both sides. So I get I is equal to 10 to the negative 7.2 power. So this is the intensity of this car engine. Okay, now we install a muffler and the noise level of an engine was reduced by 72 decibels. So it was 88 decibels, now it's reduced by 72. Find the new intensity level. Okay, so the number of decibels started at 88, but it was reduced by 72, which means the number of decibels is now 16. We want to find the new intensity, knowing that I sub 0 is 10 to the negative 16 power. Okay, so we have 16 equals 10 times log I minus log 10 to the negative 16 power. Okay, so let's divide by 10. So we get, don't really need that line I just drew there, but it's there. 16 divided by 10 is 1.6 equals log I minus, and we know log base 10 of 10 to the negative 16 is negative 16. So we will subtract 16 from both sides because that minus negative is plus. Okay, so we have 1.6 minus 16. So that's negative 14.4. So negative 14.4 equals log I. And this is log base 10, so to cancel that out, I will put base 10 on both sides. So we get the level of intensity is 10 to the negative 14.4 power.